Wow. So, good evening or good afternoon. Yeah, we have till 5 p.m. Good afternoon, ladies and gentlemen. Welcome to the parallel session 2, track 1 of Iccoins. We have 7 papers, and the first paper is from Faruk Hassan, University Technology Petronas, about acoustic emission source localization for oil and gas pipelines using machine learning technique. So, do we have the presenter already? Hamza? Hello? Okay.
Assalamu alaikum. I'm
Yeah.
Farooq Hassan from University Technology Petronas, Malaysia. The topic of my paper is AI source localization for oil and gas pipeline using machine learning technique. The overview of my slides includes introduction, literature, data acquisition, result and discussion, and summary and conclusion. Pipeline is considered a major source for transportation. It can work as economy of the nation. So pipeline failure are the main cause of critical accidents. A variety of damages causes pipeline failures like leakage, rupture, cracks, and corrosion. Corrosion is the disintegration of material into its constituent atoms due to chemical reactions with its surrounding. According to a report, 27%, 24% of the incidents in pipeline happen due to corrosion. One of the main causes in pipeline defect like leakage, rupture, and cracking. So, what is acoustic emission? Acoustic emission is a technique which is used for which is a non-destructive method. It can be used to check any kind of deformation in any structure. So, if there is any deformation, transient elastic waves are produced. Piezoelectric sensors are used to sense these waves and convert it into electrical signals. These signals are then analyzed based on some time domain, frequency domain, or time frequency domain based features. Deformation processes such as crack growth, leakage, rupture, and corrosion can be characterized. Acoustic emission has the ability to detect the location of these acoustic sources. So, many researchers have worked in the field of acoustic emission. Ibrahim Khan, he used MP model and the performance index he used for finding the location of the defect. The performance index he used were root mean square error, which was for radial it was 1 centimeter, and for tangential it was 2.4 centimeter. The same author in 2019 used stack autoencoders. And here the performance index was zonal localization error, which was 1.7 inches, and the accuracy was 44%. So the Ibrahim Khan, the same author in 2018, used compared to machine learning models, stack autoencoders, and convolutional neural network. The, the autoencoder zonal accuracy was 100%, while the CNN zonal accuracy was 95.2%. Zhu in 2018, he used the preconditioned closed form solution for on-weight estimation. So the maximum distance error here was 5.90 millimeter. The same author in 2020 uses novel weighted linear least square method without wave velocity, where the absolute distance error was 13.36 millimeter. Liu in 2020 used generalized regression neural network time domain mapping, and the absolute error was less than 2 centimeter. Ching in 2014 used wavelet neural network shuffle frog leaping algorithm, and here the error rate was less than 3%. The data acquisition setup. Here the data was acquired in the laboratory by artificially creating two defects in the pipeline. The setup includes integrated amplifier and auto sensor test capable of low frequency AE sensors R6i, physical acoustic, and the Express 8 PCI Express band 16 channel AE system and AV software. So the RCCP is the process of creating the two simulated corrosion defect. The AEN provides suitable software interface for performing hardware settings, data acquisition, and storage. It provides a platform for data analysis. This is the block diagram for sensor installation and defect identification. So the methodology here includes the analysis module is implemented using AVIN. The flow program is shown in figure 2. We can see here we get the data in a TTA format. From this data, we can detect the corrosion, and then we find out the distance of the corrosion from the sensor, and then we determine the orientation and then calculate the dimensions. This is all about the flow chart of the analysis module. So support vector regression. A support vector regression is used to construct a hyperplane or set of hyperplanes in a high or infinite dimensional space, which can be used for classification, regression, or other tasks like outlier detection. Support vector machine is a regression technique for real value function estimation. The main target of the learning process to discover a function where the approximation value is slightly minimized risk. So this is the equation for support vector regression. The training samples in SVR are called support vectors. Very few SVs are required to identify the approximation function. A specialized function, epsilon insensitive loss, has been prepared to maintain sparseness of SVR. The mathematical representation of this loss function can be written as in equation 2. So this is the support vector regression, and this is the epsilon insensitive loss function. The SVR implementation. The selection of an adequate kernel function determines the effectiveness of SVR. The kernel function has the following mathematical function as expressed in equation 3. So to implement SVR, it is important to determine the appropriate value for optimal hyperparameters, which are C, M, and omega, and epsilon, prior to building the model. Therefore, some trial and error procedure is required. The generalization ability of the support vector regression model is totally dependent on epsilon insensitive loss function, the kernel function parameter, and the regularization factor C. Base subset of epsilon and the hyperparameters are reduced through particle swarm optimization by controlling the particle velocity and location. The limitation of SVR: in case of additional hits, SVR simply picks extra hits and estimates the source location based on 3 hits at any given time. The main issue in this approach is that more than one source location are identified by an event per event. In case of any ambiguity about the timing value, source location can be extremely inaccurate. However, this problem is solved by using multiple regression analysis. Here we can see in the equation 4, the chi value is calculated based on the following mathematical equation is in equation 4. This value is also called the fit value, which depends on the coordinates x and y of the source. The sum is calculated repeatedly for each potential source location. Value of chi square is exactly 0 at the source location if the data is free from any errors. So the resultant discussion, AE data obtained from the active defect simulation were analyzed by Already data analysis module. In this analysis method, location and clustering have been performed in the AEN environment. The 2D planar graph showing the clustering result is provided here. We can see here in the diagram you can see that for defect 1 and defect 2 the actual black color rectangle are the original defects, and the cluster K5 and the cluster K5 is the strongest candidate of TF1, while the K40 is the only candidate that correspond to defect 2. These clusters are considered a estimated defect location. Based on the estimated defect areas, depth and defects are predicted using HDR model. Here we can see this is the defect 1 actual position, and this is the defect 1 estimated is estimated by acoustic emission, and this is the deviation from the deviation of the result from the original defect. Here is the same for the actual defect 2 and the estimated by AD. So the demonstrated result is an example, is an evidence that acoustic emission has the potential of parameter-based characterization of corrosion activity. The velocity of sound was considered fixed during the test. The velocity of the sound will depend upon the size, nature, and geographical properties of the material. The localization accuracy can be greatly improved by using a modified velocity. It ensures a practical and powerful method for predicting the location of the defect in the pipeline. However, the method requires much more improvement to obtain consistency in the results. That's all. Thank you so much.
Hello,
Uh,
can you
uh,
hear me?
yes, sir.
Okay, Mr. Farooq Hassan, maybe I have some questions for you.
Okay, sir.
So this application,
Yes.
have you tried it in a real oil and gas environment?
Yes, sir. Presently, we did on the in the laboratory experiment. We tried in the CCR laboratory, corrosion laboratory. We
Mhm.
uh, we had an experimental pipe. On experimental pipe, we created two artificial corrosion defects.
Yeah, where is it?
It is an University Technology Petronas in the corrosion laboratory.
Yeah, but University Technology Petronas is not an oil and gas company. So you didn't
Uh,
try it in the real environment, right?
so far we didn't try, but
Oh, okay.
yeah,
Okay, no problem. Thank you.
yeah, thank you.
Thank you, Farooq Hassan. So are there any questions from the participants of this uh, session? Okay, I cannot hear you. Is there somebody who wants to ask question, please? Mhm. Okay, if there is no question, then I think we can go to the next presentation. And the next presentation will be a novel approach to detect concept drift using machine learning. The presenter is Syed Sajjad. Okay, Mr. Syed Sajjad from Hamdard University in Pakistan. Yeah.
Today, I am Tayyab Ahmed Ansari, one of the author of this paper. The paper title is A Novel Approach to Detect Concept Drift Using Machine Learning. The other authors are Sayyid Sajjad Hussain Rizvi, Manzoor Hashmani, Waliuddin, and Muslim Jamil. These are the contents of this paper, due to which I today present the introduction. Pakistan is one of the country which has more than 60% of the population is youth, normally under 30 or 40. The majority of the population uses digital services like banking apps, payments, appointments, hospital appointments, booking taxis like Uber and Careem using the internet. The plenty of data is produced in every field of life and through using digital services. The data need to gather and process to get unknown and useful information. But it has many problems to processing the data. One of them is concept drift. Concept drift occurs when the lowest stability and change time to time, and it reduces the system accuracy level to an acceptable level. Research problem. The data concept drift is reported as one of the critical performance degradation phenomena in machine learning, especially for volumetric data. Besides that, the concept drift annotation is also one of the major research problem in the said domain. The significance of this work is to overcome the problem of accuracy level. The accuracy level problem found in different areas like fraud detection in banking areas and different criminal records, as well as climate changing, customer preference in online shopping, email spasm detection. The research will be beneficial towards the health improvement of the country and as well as in worldwide population. By an early and accurate diagnosis of diseases, also measure predict the accuracy of treatment procedures and steps. Now, methodology. Methodology is comprises of of four steps. The clustering is performed using k-means clustering algorithm. Also, the centroid of the data is calculated by assigning data points to the nearest centroid and measured using means of points. The Euclidean distance is calculated from the centroid of the data set. If Euclidean distance greater than the threshold value means concept drift is detected. Now, third steps is drift is also calculated using mutual information. If the value of the mutual information is greater than the threshold, concept drift is detected. Removing the concept drift from the data and calculate the test accuracies of each method using classification learner algorithm in MATLAB with and concept drift. Now, experimental results. To validate the performance of the proposed methodology undergoes a systematic investigation. The experimental results are outcomes are concept drift detection and position of the concept drift and testing accuracy. Datasets. C datasets is used to verify the concept drift detection. The datasets also used in numerous other concept drift detection. The C datasets contain 60,000 examples. Datasets have three attributes and three classes. The datasets is separated into two instances, are training and in testing using k-means clustering. Training instances contains 50,000 examples, while testing contains 10,000 examples, as shown in the figure. Now, concept drift detection using Euclidean distance. So researchers use Euclidean distance in various applications, few of them in image processing, incomplete data sets, and signal analysis, wireless monitoring, as well as in research, as well as in body area network. In this research, Euclidean distance is used to find concept drift. Euclidean distance based algorithm is applied to the k-means cluster to detect concept drift and location of the detected concept drift. Euclidean distance was calculated from the two centroids. A threshold was set, that is 3, to determine the concept drift. If the Euclidean distance was greater than the threshold, drift is detected as shown in the figure. You can see the distance as well in this figure. Now, concept drift detection using mutual information. Mutual information depends on the theory called concept of information. It describes the amount of information that one data has about other data. When mutual information is between the test and trained data sets are marginally interpreters of the test and trained data sets. That is a joint entropy, both test and trained data sets. The normalized the mutual information is the normal value range from 0 to 1. Researchers had used the normalized mutual information approaches in many applications. Some of them are contrast enhancements are in of breast MRI images, feature selections, major deviation, and properties of properties. Human facial expression detection, video temper detection as well. The normalized mutual information based algorithm is applied to k-means cluster to detect concept drift and the location of that detected concept drift. Our information was calculated by two centroids. Centroids are threshold level was set is that is zero point 0.8. If the threshold value is less was less than the zero point 0.8, then concept drift is detected. After that, we have verified our results. To verify the performance of the proposed method, compares the testing accuracies of 22 classification learner models with concept drift datasets that are available on MATLAB classification learning app. The non-concept drift detected was generated by removing the concept drift by using Euclidean distance and normalized mutual information. Model was trained with 50,000 examples of the C datasets. These models are evaluated based on testing accuracies. The histograms are shown in the comprises of the algorithm. The histogram shows the comparison of testing accuracies of 22 classification learner models. Each model accuracy is compared with non-concept drift detection directed algorithm. Now, conclusion. Through experimental results, it is found that both machine approaches, namely Euclidean distance and normalized mutual information, gives good results. It can solve real-world problems and healthcare problems reliably. The algorithm work well to detect drift and its location. Furthermore, the system can be trained and drift and location of for future training. A reinforcement learning and optimization approach will be used along with this approach to detect drift and training the system. For instance, COVID-19 variant can easily detect using this approach and training the system for future detection. Thank you, and thank you very much.
Okay, thank you, Mr. Sheikh Sajjad Hussain Rizvi. Is it your name? Yeah, that's a very long name. From Hamdard University, Pakistan. Before I collect the questions from the participants, I would like to ask you some questions. Is it okay? Yeah.
Yes.
So your data, which you mentioned, 60,000 something, right? Mm-hmm.
That data is
Is it a public
available.
data?
Yes, yes. Public data is available online. C data sets was taken from the
Okay, okay. So the public data, the data set you use for your calculation with MATLAB, is it actually from different oil and gas companies, or do
No,
you
it
know
is
about that?
not an online oil and gas company, but basically it is available on the internet using banking data set, which is
Or
different classifications that applies machine learning techniques to detect concept gifts.
mhm. Okay, now we can let the participants ask the question. So the current question. So I have no listing of questions here. Well, okay. If there is no question, very much again, Mr. Shade, and I know that our universities have a good cooperation, right? I hope this could be continued with other activities as well. Thank you very much.
Thank you.
So the next presentation, is from Lai Mun Chung, a company, 26 Incorporated in Ipoh. I have the opportunity to talk to her last week, and very interesting company. The topic of her is about machine learning in failure analysis of optical transceiver manufacturing process. All right, we can have a presentation now.
Hi, I'm Laiman Chung from 26 Malaysia Advanced Manufacturing Center, Sendirian Berhad. Today, I'll be presenting the application of machine learning in failure analysis of optical transceiver manufacturing process. The presentation will start off with problem statement, the proposed solution, the motivation of the proposed solution, the research background, the methodology. The experimental result consists of prediction result, drill down analysis, data-driven actions, and finally the conclusion. General failure analysis method like FMEA, fishbone analysis are able to provide high-level assessment for failure root cause. However, they are visually cluttering when more complex defects are involved and the interrelationship between causes are not easily identifiable. Other constraints of general failure analysis include human knowledge subjectivity, bias, and the importance level of parameters in an analysis affecting its consistency. The proposed solution for this study is by applying the machine learning. Machine learning as part of the artificial intelligence is a software algorithm which builds a model based on sample data in order to predict the outcome. It has no restriction on sample size, less variance, less bias, and require less time, and is a good candidate to fill in the gaps of generic failure analysis method. Motivation. So, why do we want to use machine learning? Highly integrated high-speed optical transceiver manufacturing is a very complex process involving assembly of different components and subject to multiple tests at different stages of the manufacturing process. A comprehensive analysis cross-examining all parameters in a short duration using machine learning has the edge over common failure analysis techniques, which is not possible to process many parameters or can be very time consuming even if possible. As a background, the optical transmitter operates to an internal driving chip that processes an electrical input signal with a certain code rate to drive a semiconductor laser or an optical diode in order to admit a modulated optical output signal of a corresponding rate. So in this study, a high-speed optical transceiver product has a good and stable yield for more than 5 months before experiencing a sudden drop of yield with high test failure from the transmitter. This has affected the product shipment. Common failure analysis method only points to TOSA as the possible failure cause, but did not provide deeper clues to the cause of the problem. Further investigation across TOSA is performed on 240 parameters utilizing advanced data analytics and supervised machine learning techniques to examine in an attempt to improve engineering efficiency and reduce test time and cost. The methodology of this research is divided into 3 sections: data preparation, machine learning models, test result prediction. Past 8 months data from TOSA and transceiver tests are obtained from the SQL database. Python is used in the data mining, data cleaning, and processing of 10,000 data points with 240 parameters to generate the resulting data sets. Machine learning models selected in these studies are random forest and gradient boosting for their variance and bias insensitivity. The data set is selected randomly and split into 90% training set and 10% test set. Test result prediction. The predicted results are compared with corresponding test result to evaluate the model accuracy. Cross-validation is performed on both models to ensure sufficient randomness in the training set. Feature importance chart with key parameters are plotted. Experimental result. Machine learning prediction result. Machine learning accuracy. Accuracy from both models with and without cross-validations are in 60% range. Attempt to improve the model accuracy by tuning the model parameters did not help. This could be related to the limited data size in relative to the high numbers of parameters. The accuracy of both models are comparable, with gradient boosting model performs slightly better than the random forest model. Feature importance result shows that parameter MPD dark CH3 high is scoring 6.5%. It is the top parameter in the features importance chart. Drill down analysis based on the machine learning prediction results shows that from the MPD distribution, a tri-model with distinct separation of samples are observed. Units that fail at transceiver test has lower average MPD values at TOSA test. This is further proven by MPD binning result where 25% of failure came from lower bins. A scatter plot shows that the MPD measurement has shifted. Parts below 0.4 were not observed earlier, and this brings to a deeper investigation that led to findings of TOSA subcomponents related. The data-driven decision that immediate measures to tighten the MPD specification was taken to prevent further yield loss. Analysis findings had been shared with TOSA supplier for corrective and preventive actions. Finally, for the conclusion, in this study, despite nearly in 60% range, the machine learning output is still able to detect the anomaly out of 240 input parameters, provided insights to guide deeper analysis that led to the failure course, and facilitated data-driven decision-making in manufacturing process. Machine learning is capable to uncover valuable insight among hundreds of parameters within a short time that would have been otherwise complicated and lengthy in traditional analytic approaches. That's all for my presentation today. Thank you very much.
Okay, I think the presenter has some problem with internet connection. Otherwise, she would be here with me already in the main stage. All right, in that case, then we can have the next presenter. The next presenter will be Shagufta Jabin from Air University Mulan campus in Pakistan. The topic of her presentation, or is it a he? Lockdown strategy to control COVID-19 pandemic using automata. That would be an interesting topic also for me. Okay.
My name is Shugupta Jabi. I am from Air University Multan. My topic is lockdown strategy to control COVID-19 pandemic using automata. My topic references, my agenda of topic is introduction, objective, methodology, result and discussion, conclusion, and future recommendations. As we know, COVID-19 is affecting our daily life in terms of health crisis, lockdown, poverty, education, world trade, unemployment. Like the death rate is increasing, people lives are freezing, unemployment is increasing, education sector is facing unprecedented issues, world trade is slowed down, fuel prices increased. So, our presented strategy will help to clean any area in an effective manner. It will help to get rid of lockdown as soon as possible. It will also help the people to start their business activities or to reduce the poverty, and the education sector and each impacted sector will get benefit from it. This is the methodology, we have to clear any area, any started area, then divide area, start screening, 14 days nutrition, and strict lockdown, uh, screening process again, and inside business activities. This is the static algorithm given in the paper, so we will discuss it in schema flow. This is the decision tree with deterministic approach. We have like this. We have A and B uh, uh, parts of any area. So we are taking A and B simultaneously. We have to clean them simultaneously with the strategic algorithm. In the non-deterministic approach, we can clean any part one first, and then the other part. Like we can clean a part first, and the remaining part in the other half. This is the NFA, so it is going through Q0 to Q11. So in it, Q2 to Q11 all are the accepted states. In this approach, we are taking accepting one part only, like A1 to A5 first, and then B1 to B5 in the other half. This is the deterministic finite automaton. In this approach, we are cleaning simultaneously any area. We have to clean A1, B1, and we have to accept it, and then Q3, A2, B2, and it will except on Q5 state. This is the schema flow, like we have to clean this area. So we will divide it into A1, A2, A3, A4, A5, and B1, B2, B3, B4, B5. And we will take A1, B1 first, like in the deterministic approach we are presented presenting this approach. So we will provide food necessaries in these areas. We will provide screening process. We will, and then we will um, uh, we will we will took affected people away from the area like A1 B1, and then we will strict lockdown for 14 days. After that, the screening process will done again, and in the same sense, we will took affected people away from the area, and we will declare this area as a cleared area. So in this area, the business can be started inside the area, and we will go through A2 B2 next, and so on. These are the results in the JF lab tool. So A1, B1 are accepting states in the deterministic finite automaton, and it will accepting all the states very easily. And these are the results of non-deterministic approach. So first area A1 to A5 will be cleaned first, and B1 to B5 in the next step. Conclusion, this so we can going through this strategy. With the help of this strategy, we can clean any area in an effective manner just for 14 days lockdown. As we know, the symptoms of the COVID-19 appeared in the 14 days, so it will beneficial for us to judge them on the basis of strict lockdown. And these are the future some future recommendations. We have to see that which strategy will work best, will provide us the best results, like it will be smart lockdown, complete lockdown, or the presented lockdown strategy, or something else. Thank you.
Thank you, Ms. Shagufta Jabin. I assume that she has also a problem to participate in this session, most likely because of the internet connection, because she comes from Pakistan as well. All right, so then we will go to the next presenter. The title is Advanced Data Analytics and Supervised Machine Learning in Optics Engineering Analysis by Lai Mun Chong, 26 Incorporated, Malaysia in Ipoh. Yeah, all right.
Hi, I'm Laiman Chung from 26 Malaysia Advanced Manufacturing Center, Sendirian Berhad. Today, I'll be presenting to you the application of advanced data analytics and supervised machine learning in optics engineering analysis. The outline of my presentation starts off with problem statement, the proposed solution, the motivation of this study, the research background, the methodology, experimental result, recommendations, and finally the conclusion. An optical transceiver is a small and yet powerful device that can both transmit and receive data. In optical communication, data in electrical signal is sent in the form of light pulses over an optical fiber at a very high speed and across long distance. So you can imagine an optical transceiver characterization is a complex process with many sub-processes and parameters within those sub-processes. Tuning process that only applies key parametric may not be optimized without considering other external factors. Comparing and optimizing 10 or more parameters one by one is tough. Unknown noise factor not taken into account in an analysis will add on to the challenge. The proposed solution in this study is applying machine learning. Machine learning is a software program capable to assess data, automatically learn and improve the experience. Machine learning shines when there are a lot of input parameters to be optimized. It is not limited by a sample size, less data sensitive, and more flexible. There are limited literature of machine learning in optics engineering, even though it has gathered a lot of interest in this field in the recent years. It is novel that the application of machine learning technique is first explored in the analysis of transmitter characterization algorithm of a high-speed optical transceiver module to enhance the tuning algorithm and also improve throughput. Next, I will walk through the background of this study. Optical transmitter characterization. An optical transmitter works through an internal driving chip that processes an electrical input signal with a certain code rate to drive a semiconductor laser or an optical diode in order to emit a modulated optical output signal of a corresponding rate. The laser driver current setup is the first and crucial section of an optical transceiver module setup process. In this study, 3 variants of product family selected are 1D, 4S, and 4D. They are tested with the same testers using the same software applying the dual LDI tuning algorithm. This is a 2-level tuning algorithm whereby a module is first set up at a lower laser driver current at X milliamp. If the measured laser driver current is lower than Y milliamp and the I mask margin test is less than A%, the second tuning with a higher laser driver current at Z milliamp will be triggered. When a module runs into the second tuning, it will have to go through the same sets of tests as the first tuning, leading to a longer tuning time. While the original tuning is designed to save the overall time, the effectiveness can be difficult to evaluate. The purpose of this study is to explore the opportunity to optimize the tuning in order to improve throughput by studying the effectiveness of the tuning algo through machine learning and to identify key factors for improvement. The methodology of this research consists of 4 sections: data source selection, data extraction, supervised machine learning models, test result prediction. Data source consists of structured data from SQL database, while the unstructured data are data from additional tests within the cascading tuning iteration from the test log file. Data are extracted through Python. The final data sets consists of 8,000 data points with 70 parameters. The data sets is randomly selected and split into 90% training set and 10% test set. Supervised machine learning models selected are random forest and gradient boosting. For test result prediction, predicted results are compared with corresponding test results to evaluate the model accuracy. Cross-validation is performed on both models to ensure sufficient randomness in the training set. Feature importance chart is presented. The experimental result consists of machine learning prediction results and guided analysis from this section. So the machine learning accuracy for both models with and without cross-validation score above 80%. Gradient boosting model performs slightly better than the random forest. Feature importance results. Out of 70 parameters, a key component, TOSA, from a specific supplier is found to have over 40% impact. The prediction outcome was confirmed by a 66% failure from the TOSA of this specific supplier. And further investigation actually revealed that almost 2/3 of the failure came from product 1D, where the TOSA is installed and parts failed first mass margin test and second tuning was triggered, contrary by a lower failure rate at first mass margin test is observed for product 4S and 4D. The prediction outcome and further analysis has led to the following recommendations. Optical transmitter characterization enhancement. For product 1D, start the tuning at Z milliamp instead of X milliamp to save the tuning time and to increase output. Target current alignment. Negotiate with the TOSA supplier to enable the expected yield and throughput improvements. The above implementation will potentially bring an improvement of estimated time saving between 196 to 402 seconds, or an average of 263 seconds per module, potentially increasing the UPH to 20% from existing 2.51 to 3.07. Finally, the conclusion of this research is machine learning prediction model is effective in detecting outlier out of 70 input parameters in this optical transmitter characterization analysis, provided insight to guide deeper analysis that lead to the cause of the longer tuning time and facilitated data-driven decision-making in manufacturing process. Machine learning is capable to uncover valuable insight among many parameters within a short time that would have been otherwise complicated and lengthy in traditional analytic approaches. That's all for my presentation today. Thank you. Hi.
Thank you, Ms. Lai Mun Chong. Yeah, I was informed that has also some problems with internet connection. Actually, she was also the presenter from our third paper. Right, maybe later when she managed to come, we can have a discussion with her about her two presentations. All right, then we have the next presenter, Mr. Hong Li Ti from UNTA, yeah, University Tunku Abdul Rahman. I think this one is in Kampar, yeah, not in KL. And the topic is about a cost-effective scraping and processing of real-time traffic data for route planning. All right.
Everyone, my name is T. Hong Le and I'm from University Tunku Abdul Rahman. Today I'm going to present my research, which is the cost-effective scraping and processing of real-time traffic data for route planning. I will cover the background, problem statement, research objectives, methodology, and result. In 2016, the Malaysian government, through the e-commerce transformation program, began to take initiatives to boost the e-commerce industry. One of the key entry point projects is the virtual mall project, which aims to grow the internet-based retail market. In 2018, $3.1 billion have been generated, and 3.7 billion of US dollars have been generated in 2019. It is expected to have an annual growth rate of 11.8%. However, first supporting services such as e-payments and logistics are happening in Malaysia. So, can the domestic parcel delivery service providers actually cope with the demand? According to iPrice.my, 43% of consumers in Malaysia are unhappy with their e-commerce delivery experience. Malaysia is also reported to have the longest transit time among these 5 regions. Also, more than 90% of negative feedback are related to transit time and late delivery. So, how do we improve our parcel delivery service? To improve user experience and save costs, logistic companies normally work with retail chains such as convenience stores, cafes, pharmacies to utilize their pre-established network. Senders can drop off their parcels at one of the shop's inlets and the recipients can collect the parcels from some other shop outlets to their conveniences. Then the task of the logistic arrangement would be how to collect parcels from all inlets and deliver parcels to all outlets with a limited fleet of vehicles and in a given time window. This can be formulated as vehicle routing problem. However, traditional approaches for VRP normally assume that the traveling costs are known before the planning, and the cost estimation might not refer to the real traffic data in the past, which may result in poor planning, even if the algorithm could be robust. Thus, there is the need to study the real traffic data in the past, pre-process this data so as to generate more reasonable cost estimation to the VRP for route planning. The research objective is to provide route planning algorithm a set of input time cost data that is formulated based on past traffic patterns. In order to achieve our main objectives, we have to collect real-time traffic data of pickup and delivery vertices by scraping real-time traffic data from Google Maps. Also, we need to pre-process the collected traffic time cost data so that the illogical paths can be patched, hence the iteration time for web scraping can be reduced. Cost in terms of traveling time may vary subject to traffic condition. However, there is still patterns of traveling time between 2 points. For instance, during peak hours, certain paths will be much more congested than the others. In order to get the past traffic data, our solution is to scrap it from the Google Map. In real-world scenario, vertex is actually equals to a coordinates of parcel pickup and drop-off point. Arc is actually the time cost between two vertices. A graph with fully connected vertices is needed to find out the least time cost routes between two vertices. Assume that n equals to the number of vertices, there will be n times n minus 1 number of arcs to construct a fully connected graph. It includes round trip because the time cost from A to B isn't equals to B to A. The example of construct a fully connected graph is shown here. Let's say we have 4 vertices. To construct a fully connected graph consists of 12 arcs. There are also other approaches. One of them is Google Distance Matrix API. By referring to the pricing table from Google Distance Matrix API, assume that we have 68 vertices. To construct a fully connected graph, it requires 4,556 arcs. Let's say Google Distance Matrix API is used to collect 24 times of fully connected graph per day. It costs roughly $433 per day and $13,000 per month. The advantage of using Google Distance Matrix API is it does not require much implementation. Also, it will have better performance. However, it is very expensive. The other approaches is using local GPS service provider. By referring to the pricing table from iFleet, assume that the GPS service are allocated into 50 vehicles. It costs $853 per month. The advantage of using GPS service provider is it provides higher accuracy to trace the vehicle in real time. However, the fleet of vehicles may not collect all arcs at all possible time while traveling. Hence, it is also expensive. As comparison, developing a web scraper is the most feasible solution in our research. Also, the challenge for real-time data collection is we need to collect the real-time traffic data as frequent as possible so that we will have more information of the traffic data. After collecting the traffic data, we have to pre-process the traffic data for vehicle routing optimization. We found out that Google Maps does not always provide the shortest paths between 2 points. Such illogical time costs should be patched so as to improve the correctness of subsequent route planning algorithm. Let cost xy equals to the time cost estimated by the Google Map to travel from point X to point Y. If cost ik is larger than cost ij plus jk, the scrap data violates the triangular inequality principle. Hence, the arc of ik needs to be patched to ik equals to ij plus jk. For experimentation and results, A traveling salesman problem algorithm benchmarking is carried out between original arcs graph and patch arcs graph. Each iteration of collected real-time traffic data are grouped according to different time per hour. For example, 1 a.m., 2 a.m., 3 a.m., 4 a.m. Train test rate is performed with 85% of training set and 15% of testing set. In training set, if more than 70% of a particular arc violated the triangular inequality rules, it will be patched with the sum of shorter arcs. Then it will form a patch arcs graph to be tested in the testing set. For example, more than 70% violated triangular inequality rules for cos ik in training set. So, cos ik in testing set is patched with another combination of time cost arc. It could be ij plus jk or il plus lm plus mk. According to the outcome from the training set, an average of 34.26% of arcs can be patched with shorter arcs based on different hour. Also, by referring to this table, it indicates that patch arc graph is more likely to provide shorter route than original arcs graph in solving TSP. By referring to the collected traffic data, a traffic pattern can be found and proven, which there are two crests around 7 a.m. to 8 a.m. and 6 p.m. to 7 p.m. The contribution of this research is the real-time traffic data can be collected dynamically with very cost-effective method. Unlike the static time cost arcs, VIP algorithm can be applied in real-world situation which consists of real-time traffic data that varies over time. The estimated transit time can be improved after considering real-time traffic data in the VIP algorithm. Hence, the result of delay the transit time can be reduced. In conclusion, real-time traffic data are collected dynamically with a very cost-effective method by developing a multi-threaded web scraper to scrape the data from real-time traffic maps website. Efficiency of web scraping is improved as data preprocessing phase patch the arcs that are illogical, so that these arcs are not needed to be scrapped again according to different time. That's all for my presentation. Thank you.
Yes, thank you, Hong Leti, for your presentation.
Thank
Okay,
you.
yeah. You are from Utah in Kampa or
In Kampa.
in Kampa? So very near, yeah? So about 22 minutes or something like that. All right,
Oh,
so
yeah.
before I collect questions from the forum, I would like to ask you some questions. According to your experience, how accurate is the GPS data, the real-time traffic data?
Sorry again. Oh, the GPS data.
According to
It is collected from the Google Map, which when we just like we search using the Google Map, but it is developed using multi-threaded way, which is around 16 tabs, and then it will just keep on searching the required coordinates from time to time. And and we can't define like how accurate it is because
because you didn't measure by yourself.
we it is not possible to measure by ourselves, like, yeah, because there are so many different arcs.
Okay, my second question is of your experiment of your project. Have you discussed this with, well, organizations which require such service as real-time traffic data?
Yes, we have approached to some logistic company, which is Easy Parcel, and we had discussed about this problem.
How is their feedback, please?
They based on the result, they are quite impressed, like how actually the Google Map provides the data that is not completely true. As the result that are shown, 34.26% of arcs can be patched, which means that the 34.26% of the arcs are actually not the optimum path provided from Google Map, because we can find like another alternative path from the data that we collected.
Okay. Thank you for your answers.
Thank you.
So I have a question yet, but maybe later they can ask you by. Okay. Okay. Mr. Hong Leti.
Thank you.
Well, since Ka is very near to you, maybe I don't know when we can communicate with each other, right? Maybe physically. All right, that would be nice. Okay, so the next presenter comes from Germany. Yeah, Mr. Joseph Mabur, who used to be our student at University Technology Petronas, Malaysia, with the topic of multi-population generic algorithm for rich vehicle routing problems. Joe, come and present.
Assalamu alaikum and good day everyone. I'm excited to be with you here to present about our paper, Multi-Population Genetic Algorithms for Rich Vehicle Routing Problems. My name is Joseph Mabor. I graduated from UGP with Bachelor of Information Technology, specializing in software engineering last year, and I currently worked as a software engineer in Germany at EDI GmbH, Engineering Data Intelligence. And so the paper that I'm presenting is a solution to a problem that was faced by Petronas. So actually this research was funded by Petronas, and the problem is that Petronas has a lot of petrol stations throughout Malaysia, and they have to send drivers to deliver oil trucks to these locations. So the question is, how does Petronas deliver these oil trucks to different locations at minimum cost? So it's a problem of logistical planning. And before I continue with the presentation, I would like to acknowledge and thank uh, the incredible people I have worked with on this project. Without their work and support and guidance, then this work might not have been, would have not been this successful to even to be presented today. I would like to thank Dr. Yu Huang Hui, that was my supervisor, and my co-supervisor, Dr. Mohammed Nordin bin Zakaria. Their work was really very important in making sure this was successful. And my presentation will basically talk about the background of these problems, the literature review and methodology, and then I will present to you the results and discussions, and then conclusions. So the time is very limited, so I will try to squeeze everything as fast as possible. So as I stated earlier, so this is a problems of trying to blend the delivery of items of oil trucks to different to different petrol stations or to different customers. If we are talking about logistic companies, as we have witnessed in this pandemic, we see that online transactions has increased a lot, and this put pressure on the logistic companies to find some ways they can plan and deliver orders to the customers at minimum cost. And these problems is basically called vehicle routing problems in academic. And so we basically can decide to say what is our idea of minimum cost. So we can optimize distance, we can also optimize durations or the cost or the number of drivers that we want to use. And with this, we call it rich vehicle routing problems because we are basically trying to optimize multiple objectives, multiple problems. This will make it become multi-objective VRP. And yeah, so we could optimize distance or durations or route cost. And so in academic research, uh, these problems is better solved by evolutionary algorithms, which are inspired by nature, because we cannot really use a brute force algorithms that try to find every possible route. That will take a lot of time, and computer cannot solve that. And the most popular evolutionary algorithms is uh, genetic algorithms. These are kinds of algorithms inspired by the survival of the fittest, yeah, our evolution theory by Darwin. And basically, what happened is that we have a number of populations, and the theory is that if we intermarry certain like strongest uh, individuals in a population, then in next generation we get even better individuals, more stronger ones. And in terms of our problems, if we interbreed, if we have a population of possible solutions and we get out solutions that are more fit and we interbreed them, we will even get more fitter solution in the next generation. This is the basis of the algorithms. And so the problems with this approach is that, of course, it will find optimal solutions, but it finds optimal solution. Why? Because the population, if the population is small, like just like if you marry from relatives or closer people that are closer to you, then you're likely going to uh, uh, get children that probably have diseases, if you also have diseases. And also, if we only say this population, the size of the population, let's say half of the population is only good for interbreed, to interbreed, then you are actually getting rid of half of the population. And it could be possible that from the populations that you ignored, there is a possible solution that if you interpret with another solution, they will even get a better solution. And this is actually called premature conversions. So where we get solutions suboptimals, and this is what we want to solve in our solution with multi-population genetic algorithms. And yeah, so basically we are going to create algorithms that try to diversify the populations in a way that we do not get suboptimal solutions. And the scope will be to optimize three objectives: distance, time, and cost. And we are going to evaluate these algorithms with a benchmark, which is mostly used in the industry, in the research now, multi-objective genetic algorithms, MOGA. And yeah, so there has been a lot of works that are related to uh, parallelization, or what we call multi-populations. So we're basically using parallelization to have different populations. And these solutions, the most popular one is island modules, and it has been successful in terms of reducing the time complexity so that we can get the solution much faster. However, they did not focus on optimizing the solutions. And this is where we come in and get inspiration from these island models, and then we use it for increasing the diversity of the populations. And this is where our algorithms was born, multi-population genetic algorithms. So we basically have different uh, genetic algorithms, different slaves, different populations that share information, that not just information, but that share migrant, that share individuals in the population. So when each population basically will optimize a solution, and if after a certain number of generations, they will share the slaves, sorry, they will share the individuals in their populations, and they will be added in the local populations. And this will increase diversity and reduce and get rid of premature conversions. And this is the details of the algorithms. So basically, we have a master slave that starts the algorithms, the populations, and they will tell each slave that has a population that this is objective that you want to optimize, and then the slaves will be coordinated by master, and they will be able to share migrants, what we call migrants, like individuals in the fittest individuals in these slaves, and the fittest individuals in these slaves, they will be sent to the master, and the master will reshuffle them and send them to respective slaves, and there they will be added into local population. They're increasing the diversity. And we evaluated these algorithms, and the result we found that are very promising, very good. We found that the performance of the algorithms to get the optimal solution increases with the increase in the rate of populations, sorry, in the rate of migrations. If we increase how many migrants we need to migrate, we need to send to different slaves. It increases until 40%. After it reaches 40%, it becomes diluted and is not working anymore. And we find that, yeah, the optimal rate of how many number of migrants we should send, number of the percentage of the population we should send to different migrants, different slaves, is actually 30 to 40%. We found that our algorithms perform much better in getting the optimal solution, and also it's more reliable, 40% compared to 20% of Moga. And we actually also get that it is also faster than Moga. And if you look at the graphs, you see that this is the distance we want to optimize, and we see that with this 30 to 40, we get better solutions, which is 332 or less. But if we increase the migration rate, we actually diluting the population, and we are not getting better solution anymore. And you also see that with over different generations, you see that the Moga will get optimal solution much faster because of more diversity at the almost, I think, 15th generations. But with our algorithms, it continues to improve until even 19th generations. So meaning that the diversity is improving the optimality of the solution. And you see that we also, this is the distance we want to optimize, and we are actually getting minimum distance over the population size. And you see here, we're getting less optimal solution with Moga. And we also see, like I said before, the reliability is improved in multi-population genetic algorithms compared to Moga. And another interesting finding is that, yeah, like I explained before, it's actually improved the timing, the time complexity. We see that the Moga is exponential with the size of the problems, the size of the populations, and our algorithms is linear, which is actually a big improvement. Yeah, yeah, and basically, just increasing the diversity in populations increases the optimality of the solutions, and also just using parallelization increases the time complexity. Uh, and this is very, very good results. And so we can conclude that our algorithm outperformed our benchmark, which was Moga, in terms of consistency, in terms of optimality of the solutions, and also in terms of time complexity. And so the future work should focus on studying more the possibility of making one population, one slave optimize one objective. Now we only one slave optimize only one objective. But what if multiple slave optimize that the same objective? And also we should study the architecture, the better architecture that could be used. This architecture could be improved, and so our work is really important to the research community. They can improve on this. And this, if you have any questions, so you can ask. Thank you for listening. My presentation uh, ends here.
All right. Thank you, Joe. Before people wonder, I would like to inform you that Joe come from South Sudan. Was born in South Sudan. Is it correct?
Yep.
He studied in Malaysia, and I sent him for internship in a company in Germany, and he liked Germany very much. Now he is working in Germany. Is it correct, Joe?
I
Yeah.
also like Malaysia.
Oh, you also like Malaysia? Okay. Maybe you can come after all this pandemic situation to Malaysia. Yeah, back to Malaysia.
Yeah.
All right, Joe. Before I give you to the forum, I would like to ask some questions. So first question is, have you actually compared your result with other AI algorithm besides the genetic algorithm? And the second one, okay, maybe could you ask the first question first?
Yeah. So in the industry, we found from the research that we did, we found that multi-objective genetic algorithms was widely used to solve these problems because it provide a better solution in reasonable time. So we only take that as an objective because we are solving multi-objective VRP. So our algorithms, we only compare it to the multi-objective genetic algorithms and not with other algorithms. But if you also compare multi-objective algorithm with other algorithm in the industry, yeah, it was reasonable to actually use multi-objective genetic algorithm because it provides a better solution at reasonable time with medium to large scale problems. So that's why we chose it.
Okay, thank you. So I worked actually at Siemens before, and one of my client was an oil and gas company in Riau. As I visited this company, they mentioned also similar problem they have to track their drivers, right? It was some times ago, maybe even in 20th century. But they had this problem. Now, my question is, does Petronas have this kind of problem? Also, like the drivers are not to be tracked, etc., because time is money, yeah? And is this the main reason that Petronas ask you to do this kind of study or research and development? Yeah.
So the main problem is not about tracking the drivers, but finding optimal way to deliver trucks
Oh, okay.
for planning, basically. And so this algorithm, so the proposed solution was to find a way we can plan routes, and then we can actually assign drivers to this specific route, and basically this should minimize the cost. And instead of just saying using manual planning of the route, so because if you plan a route manually, maybe that route is not minimal, but these algorithms will actually give you routes that are optimal, and then you can assign them to different drivers. So the problem of Petronas was how do they plan the delivery of these oil trucks to different location at a minimum cost in terms of sending few number of drivers. So if you send few drivers to deliver the trucks, the oil trucks, then you're actually reducing the cost. If you also reduce the distance, then you're also reducing cost. So this was the main problem.
Maybe a follow-up question. We actually have apps like Waze, for example, or Google Map, which can even count the time you arrive from one point to another. So why didn't Petronas use Waze or Google Map instead of your system?
So so we actually use Google Maps to collect the data for different points, but Google Maps will actually tell you the shortest distance from point A to point B. That will give you the shortest distance. But so what you are doing is that, okay, you use Google Map to get you a distance from point A to point B, but you also use Google Map to give you a distance between point A to C and or point B to D. But you want to deliver oil trucks to the same locations. So you actually need another customized algorithms to take the data that you have, like many locations that you are sending to, give with the given durations, sorry, with the given distance, and also you also need there to add the cost, and you also need to add also the number of drivers that you can use. So this one Google cannot give you. So you have to use these algorithms to actually optimize many objectives. So Google will only give you probably time and duration, but you also need to add other objectives like the number of drivers that you can use and also the time window that you have to deliver the item. So it needs another customized algorithm to do this.
All right, Joe. I'm happy that you are happy in Germany, although you are also happy in Malaysia. But you have to choose. You cannot be in two different sites at the same time. Okay. All right. I think those were the questions. Thank you very much, Joe, and hope all the best. For your uh, stay in Germany. All right. Maybe it is
Thank you.
for. Okay. Thank you, Joe. Now, actually, Miss Lai Mun Chong wants to join us for this session, but she had some problems. So I don't know. Can I know whether she is now available? All right. Because she came here for rehearsal last week. I'm sorry to not seeing her. Anyway, we come to the end of our session, although it's still 6:30. But I think we had good presentations, good systems. Although two of the presenters could not join us, but very international actually. We had from Pakistan, Malaysia, and South Sudan, who is now in Germany. And thank you all for your participations. And we wish you all the best and hope that we can meet you again very soon, maybe face to face. Who knows? Yeah. Thank you all, and till next time. Yeah. Auf Wiedersehen in Germany. Okay. Bye.